Hi everyone, my name is Dain. I'm a PhD student at UCLA. It's my great honor to present our work, Broaden the Vision, Geo-Diverse Visual Common Sense Reasoning. This is a joint work with Harold, Ziniu, Professor Nanyun Peng, and Professor Kai-Wei Chang. Let's first start with the definition of common sense in Wikipedia. Common sense is a kind of basic ability to perceive, understand, and judge in a manner that is shared by nearly all people. And here we notice an absolute argument that mentions nearly all people. We may wonder, is all of the common sense knowledge shared by all people? If not, what else should we also consider? Then I want to show you an example about weddings. We may directly think of the wedding scenes like the three pictures below. The bride wears a white dress and the groom wears a black suit. White flowers are surrounding them, and the wedding witness may stand by them and read wedding vows. The items like white dress, black suits, and white flowers are typical characteristics of weddings. However, do all the weddings look like this? The answer is no. This page shows some other wedding scenarios in other regions like Eastern Asian, South Asian, and African countries. Here we can't see brides in white. We can't see the groom wearing black suits. We also can't see many white flowers from the pictures. Actually, for example, in traditional Chinese weddings, brides often wear red and their faces are covered with red clothes. This means that the common sense knowledge about Western weddings doesn't apply for all the weddings in non-Western regions. We can also notice the same situations for other everyday scenarios, including funerals, religions, and festivals. Based on the previous observation, we find that common sense knowledge isn't invariant across the world. Common sense is more diverse than we thought. It may change region by region due to historical and cultural factors. In other words, common sense is actually geo-diverse. In fact, some current common sense reasoning datasets are composed by data from sources in certain regions. Here we take VCR, Visual Common Sense Reasoning Dataset, as an example. The others constructed their dataset mostly based on the videos in Movie Clip YouTube channel and LSMDC datasets. However, those movies are mostly Western movies like Hollywood movies. Here we are concerned that such datasets may overlook the differences across groups in different regions. If a model is fine-tuned on the dataset, and therefore incapable of capturing nuanced regional characteristics, we speculate that it will lead to a large performance disparity across different regions. This motivates us to study how well a model trained on existing common sense adaptations can generalize to tasks requiring common sense beyond Western regions. In this paper, we introduce a new evaluation dataset, Geo-Diverse Visual Common Sense Reasoning, GDVCR. Our GDVCR dataset follows the settings of the original VCR dataset. Given an image with bounding boxes, models should answer multiple choice questions about some detected objects according to the image contents. And visual common sense is usually needed to answer these questions. We mentioned that the images of the original VCR dataset are mainly captured from Western movies. In our GDVCR dataset, we collect the images from not only the Western countries, but also Eastern Asian, South Asian, and African countries, so as to have a broader coverage and make our dataset more geo-diverse. The goal of constructing GDVCR dataset is to evaluate models' reasoning ability on the task which requires geo-diverse common sense. An example is given in the right. Suppose we have images from different regions with the help of questions which involve geo-diverse common sense, like what are person 1 and person 2 participating in. It can manifest how models behave differently and reveal some potential issues. We show the statistics about GDVCR. Our GDVCR has 328 images and nearly 900 QA pairs. The QA pair distribution can be seen in the left corner. We then calculate the statistics about the text length of questions and answers and the numbers of image bounding boxes. We observe that there's no evident difference among regions. We also calculate the OOV rates for each region, which means the ratio of words that appear in GDVCR but not in the original VCR training set. We find that the OOV rates are close to each other and all the 4 rates are low. It further demonstrates that GDVCR has a similar distribution of the vocabulary with the original VCR dataset, and the difficulty of GDVCR does not come from the vocabulary gap. In the experiments, we evaluate visual BERT and VIL BERT on GDVCR, and the evaluation process is shown below. We first fine-tune the 2 models on the original VCR dataset, and the second step is to select the epoch with the highest performance on the original VCR development set. Finally, we will test the selected models on GDVCR. So here we provide comparison results based on the model and human performance. First, we find that the 2 models perform significantly worse on the images from non-Western regions compared with Western images, and the gap is from 3% to 19%. Secondly, we compare the model and the human performance. So here we recruited annotators from US and UK to do the test. We noticed that though humans may not be familiar with the culture, they still outperform models by around 30%. It implies that human beings are more capable of applying their common sense knowledge and transferring it to the comprehension in geo-diverse settings, while models are still far away from this level. So actually, we have observed the performance disparity, but where does the performance disparity come from? In the following parts, we will analyze the reasons behind such performance disparity on 2 aspects. The first aspect is the regional differences of scenarios. As we mentioned in the beginning, even the same scenarios such as weddings and funerals can take different visual forms across regions. Motivated by this, we investigate how large the performance gap is when we apply visual BERT to the images about the same scenarios across regions. We compare model performance on these images. Here, note that we annotate the scenario keywords of images in GDVCR, so we can do the comparison with the help of the keywords. We observe that for the scenarios which often involve regional characteristics, the performance gap is much larger, which is from 8% to 24%. The second aspect we analyze is the reasoning level of QA pairs. Before we talk about the reasoning level, we can first think of when the model fails. There are 2 situations. Situation 1 is that the model even fails to recognize the basic visual facts from non-Western images in the early stage. Situation 2 is that the model performs similarly on the basic facts, but fails eventually due to lack of geo-specific common sense. To judge which situation we are in, We additionally annotate low-order cognitive QA pairs. These pairs can be directly answered by recognizing basic visual facts. So here is an example. The question, what's person street wearing, is a low-order QA pair, and the reasoning level of low-order pairs is low. And we assume that all the QA pairs in the official GDVCR dataset are higher-order pairs because they involve common sense and more complex reasoning. So the reasoning level of high-order pairs is high. We also evaluate visual BERT on these QA pairs. We first notice that the performance on low-order QA pairs is higher than on high-order QA pairs. And we notice that the disparity across regions on low-order QA pairs is much smaller than on high-order QA pairs. It means that the model can achieve similar performance on questions about basic facts, but the complex reasoning on common sense brings difficulty and enlarges the gap. It also means that situation 2 better describes the situation. In conclusion, in this paper, we built a new Geo-Diverse dataset, GDVCR, and we evaluate the model performance on GDVCR and find a large disparity across regions. Finally, we analyze the sources of this performance disparity. For broader impact, we hope this work can broaden researchers' visions on the scope of common sense reasoning field and motivate researchers to build better common sense reasoning systems with more inclusive consideration. Here we provide the links of dataset, code, and project page. For more details, please refer to our paper. Thanks for listening.